As promised in last week's video, this is the Shaper Q&A. I received a lot of questions during the week and I think now you can witness something rather unique on this channel. I took notes. So you bought yourself a brand new to you Shaper. Congratulations. Or maybe you want to buy some or whatever. What I did on my machine, I made this foot, this is 150 mil higher, because this machine was too low for me. And a typical question that comes back is, should I bolt down the Shaper to the floor? Absolutely. This machine is bolted down, of course, on the frame, and the frame is bolted down in the concrete. The problem I have here is that this concrete slab is very thin and poor quality, so I have to be very careful with it. And here's a nice example why you should bolt down your Shaper. According to this chart on the side of the Shaper, the maximum cutting speed for this machine is 50 meters per minute. Now this chart is not correct. It takes in account the average speed of the bull gear, not the actual cutting speed of the cutting stroke, but whatever. 50 meters a minute. If I run my machine at 160 strokes, the maximum stroke length will be 110, for example. Let's have a little look to what it looks like. According to the chart, this is 50 meters a minute. As you can see, it's a little bit violent. The cutting speed we use on this kind of machines and several times on the lathe also for mild steel is 20 meters a minute. For aluminium I'm not sure, but we are here in the range of cutting aluminium, and that means a piece with about this length, a little bit less than 100 mil. That is a totally normal cutting speed. So don't tell me Shapers are slow. I can totally understand that you want your Shaper on casters or wheels, or that you can move it. If you have a milling machine, the Shaper will be less used. I think it makes sense, right? So the day you need it, you roll it out, you put the feet down, use your Shaper, no need anymore, put it back in the corner, let it sleep again. I understand. If you do that, make sure that the base that you make with casters, that the Shaper itself is bolted to the base, and the base with nice steady feet spread out, steady on the concrete. Otherwise, if you run the Shaper at a supposed speed, you will have a problem. Should the Shaper be level? No, of course not. We don't care at all. All it has to do is make straight cuts. If your Shaper is level, it's maybe handy if you want to use the clinometer to put parts in an angle, in a special angle, could be really handy. But there's no need. This Shaper is not level. think.
Nope, it's not at all.
Is it possible to accidentally, of course, run the shaper in reverse, which means that the backstroke will be slower than the cutting stroke? Of course. Now the shaper is running the wrong way. Here we can clearly see that the backstroke is faster than the cutting stroke. I think the best way to check it is to watch the central shaft here. This shaft holds the bull gear. Yeah? If the bull gear runs the right way, the cutting stroke will be slower than the backstroke, which means this side is a cutting tool, this thing, so this must turn this way. Let's check. I hope this is convenient. Now, I have personally absolutely no problems with people making mistake in running the shaper backwards. But I came across two completely different videos filmed in a school where I see the shaper running backwards. In a school where you have to learn things, how to do it. Let me show you why it's not a good idea to run the shaper backwards. In theory, it doesn't make much difference, right? But it does. Here's why. I have here my wooden shaper model with the bull gear, of course, the crank pin, the rocker arm, and the ram that now is fixed on this board because, right, let's say the cutting tool is that way, cutting action that way, so my shaper has to run this way, okay? As we said on the real shaper, the direction of the cutting tool. Which means, during the cut, this side of the rocker arm, and of course the crank pin, takes all the loads. This lever is long between the pivot point and the crank pin, long lever, so it can handle these forces without any problem. On the backstroke, the lever is short, but there's no cutting action, there's no forces involved, or almost no forces. And this is also the moment where your shaper wants to tip over, because the ram is completely in front and then quickly returns, and that's where your shaper tends to lift to the front side. A shaper will rarely lift to the back side, almost always to the front. If the shaper is running backwards, wrong way, right? This cutting, ram, go away. The cutting forces, short lever, big force, right? Don't mess up your machine, spin it the right way. Another good reason to spin your machine in the right way is of course because of the oil. In my machine over here there is oil, swamp oil bath, I don't know how you want to call it. If this is the pinion, little drive gear that drives the bull gear. Machine should spin that way, okay? The oil is picked up by the bull gear And over here, just after the center, is a little steel plate. It used to be copper, but it broke, so I changed it. Now is a steel plate. The oil climbs up this plate and then leaks. I'm gonna show it here. And leaks on the rocker arm and the crank pin. Yeah, that's the idea. So there's no oil pump in this machine. This is the only oil system there is. To oil the bearings, there is a little pipe that goes from just below this steel plate to the bearings. I think that's a very simple concept. Can't fail. If we run the shaper the other way around, oil will indeed be picked up, but bumps here and will never climb up this little steel plate and will never run in the pipe and will never oil the rocker arm and the crank pin. Of course, it's not because this machine has an oil bath that I don't need to put oil. It's very important to oil the ram. It's these three and three on the other side. And of course the table and the feed mechanism. Don't forget. So your brand new shaper is installed. You finished restoring it, all cleaned up, all ready to go. But first you want to take some measurements. And here we see there is a problem. 0. This is 50 microns of, it's not a lot, but for precise parts it's too much. So maybe the first idea we have is to recut the surface of the table. On the shaper it's perfectly possible. It's one of the rare machines where you can recut its own table with the machine itself. Don't, because you just assembled the whole zwig and you see there's a difference here. You still don't know where it comes from. If we move the ram completely out, this is almost full stroke. Take a piece of wood and put it here under the ram. Here is some movement, right? But we don't know where the movement comes from. Is it the table that's going down, or is it the ram that's moving up, or maybe is the tool slide moving? So my little advice: to start with, use a very stupid cheap little vase. This costs almost nothing. I always make sure that this one is installed same way, right? So what I did, I took all my vase apart, installed it, trimmed it in, yeah, square, and then with very light cuts recut these two surfaces. So even if the table of the shaper is off, or the ram is moving or whatever, the vise will always be in line with the ram. From the moment your vise is okay, you have about the rest of your life to figure out what's wrong with the shaper, why the dial indicator is moving, and then use your shaper and you will see it will move again and again and again. And when the difference is consistent,
then you can recut the table.
Because I never recut the table of this shaper, I'm gonna leave it as is. Well, I did my daily use little vise here. I did exactly the same. Bolted down at exactly the same spot where I always use it. I took it apart and recut these two surfaces here, and now I'm sure every time I mount the vise on the shaper it's in line with the ram, and it works like a charm. Because I don't have any specifications for this machine, I don't know anything about measurements, I don't have paperwork for it, and that's the typical problem on all the machines. You can find the machine, but the paperwork nobody has. So what I do to put the ram in place, I make sure, if this one is loose of course, that it can slide easily, and with my indicator on the side of the table make sure there's no play, and I do that on different places. So like this, it works perfectly fine. Of course, if you have a very big shaper, for example these hydraulic shapers, Klop made these shapers, hydraulic systems, I have to admit I have no idea how to fix the ram in place that you have the exact right drag. I don't know, I can't help you with this, but these small things, easy peasy, do by hand, works perfectly fine. Same with the tool slide. Make sure there's a bit of tension on the gib, that there's no movement, otherwise you're working on a part and you want to dial in 1/10 of a millimeter. It's not much, so you set your dial indicator 0. You loosen the tool slide, dialing 1/10, tight again, and we're here almost at 3/10, because when you loosen here, that's the problem. Of course I did this now on purpose. What brings us to the cutting tools. As you see, I have here a small collection. This one I made especially for the shaper. It was a carbide in the shaper test. There's a video in my playlist with a little piece of leather to protect the thing on the backstroke. Now, there was a question about carbide in the shaper. I have to admit I never been too lucky with it. I see many times on shapers this extended shaper thing used. I use this as less as possible, because this is a heavy piece of equipment and it makes suffer the clapper a whole lot more. Now this is handy, you can put it in whatever angle, use it this way or that way, all choices are open. And then I use this round nose tool in it, so I can choose in whatever angle I use it. This is about 60 degrees. Works perfectly fine. Right, the tool I use the most is this one, and this is exactly the same as we use on the lathe, except that it's cut in the other way. This one is more or less the same. One is left hand and the other one is right hand. I use both tools on the lathe and on the shaper, and in fact all of them. And this is my special tap shear tool. This one works perfectly fine. Let's have a look at this one from close by. This tool is the most used
tool in the shaper. If you have one like this, you can do 95% or maybe even more of the work with one cutting tool. Because this angle, if you look it this way, the tool cuts out of the blackboard into the camera, yeah, this way. We have less than 90-degree angle here, so we can make right shoulders. There is a relief between the 90-degree shoulder and the tool somewhere between 2 and 4 degrees. It depends what angle you set it. Of course, you change this angle, you change this angle at the same time. The face has 1 or 2 degrees back rake, is that how you say? It's leaning backwards about 1 or 2 degrees. It's not need to give it more, otherwise your tool tends to dig in the material. I think it's better to give it less back rake than too much back rake. That's my experience on my machine. Maybe on your machine it works better, but here it's like this. Right, let's look at the bottom of the tool, the typical diamond shape. And this tool has 7 degrees side rake and 7 degrees clearance. Why are these two angles here 7 degrees and 7 degrees? Because when I grind my tool here on my bench grinder, automatically it will give me the 7 degrees one way and the other way also 7 degrees. That's the only reason. To make your tool live a little bit longer and give a nicer surface finish, we also give it a nose radius. The nose radius does a couple of things. First of all, the surface finish will be smoother. Yeah, every stroke. Now, the width of the radius you make here, make it 2 or 3 times the feed. If, for example, your machine, you want to feed 2/10 of a millimeter, make it 1/2 millimeter or 6/10 or something. Now, it's not really important, it's not really a precise radius, because every time you're gonna regrind your tool, there will be a little bit of changes, of course. What this radius also does, if we cut a chip here, right, the chip will curl. Because the angle of the tool, the chip will curl down and is gonna rub on the finished surface. So, escape. Because of the radius, it's also cutting on the bottom side of all this radius. And here the chip will curl up. As a result, combined forces in this chip, and the chip will evacuate upwards, will not touch the finished surface. One thing you have to take into account is, of course, the bigger the radius, the more cutting force you need. Some time ago I made this gib on the shaper. And there was a comment from ToolTime Chris from the Netherlands, and he let me know that he has exactly the same shaper as I have here, but he's missing the gib for the tool slide. So I respond to his comment, no problem Chris, I can send you this one if you want. For the moment he doesn't have really much time for it, and he's working on a new workshop, and so he has to take measurements for his gib, and for the moment he knows if it's gonna work or not. I can send him or not, we will see. But to say thank you in advance, what he does, he sent me a nice little box with a very friendly little note. His Instagram sticker, I hope it's not too much glare, it seems to look good. He also has a YouTube channel, so go and have a look at Chris' channel. I will put a link in description. And this is what he sent me. And no, these are not made in Germany C-clamps. These are really micrometers, and they feel better than new. So ToolTime Chris in the Netherlands, thank you very much. I really appreciate it. And if you see that this gib doesn't fit your shaper, not a problem. Give me the dimensions and I will make you a new one that really fits. And I also received this mug from Greg in Ohio, because he did a 1K subscribers draw and I won this one. And as you can see, the thing arrived in one piece. So check out Greg at My Lil Mule channel, of course also link in description. And what I like about Greg, he's not afraid to use his shaper to make something. So you just made a brand new cutting tool. You have all the angles right and it should perform as a charm, right? That's not always the case. It happens sometimes. You make a tool, it works perfectly fine. You make exactly the same tool and it doesn't work. I never could figure out why, but it happens. To illustrate that one tool can perform different, we're gonna do a little test here. I have two marks on this useless piece of steel that suddenly becomes useful. I will cut 1/3 of this surface at about 7 meters a minute cutting speed. The second third I will cut, do it in one go. I will bump up the speed at about 18 meters a minute. And the third I will continue the same cutting speed but put some cutting oil. And I hope the camera after will pick up the difference in surface finish. I will bring you closer and speed the video up. Let's do this. I had to take it out of the vise because the shiny surfaces of the vise gave too much glare. Here you can see the two witness marks left, no problem. And if I turn it around a bit in the light, I hope this little camera picks it up. But this side, the right side, is rough. I can even feel it. The middle part is much smoother. And the left side, where I put cutting oil, is even better. There's not much difference between the middle and the left side, but it's visible and you can even feel it. And if we watch carefully, we see that here in the beginning of the cut, the surface finish is always almost perfect. It looks very nice and shiny in contrast with the rest. And this is of course because here, when we start the cut, there is no chip.
Same workpiece, same setup, same cutting tool, 3 different results. So even if you make the perfect cutting tool, I think it's better to experiment a bit with it and see what happens. To make my high-speed steel cutting tools, I use 10mm square high-speed steel. If you have 2 of them, you can make whatever you want on your shape. I think this 10 by 10 is a really good choice. It's of course my opinion. Now, don't be afraid to spend a little bit more money to have quality. This one is 5% cobalt. This is another one. It's not a 10 by 10 but a 3/8 square. It's a little bit smaller. 8% cobalt. You can buy these for somewhere between 10 and 20 of your local money, right? So you spend between 20 and 40 bucks, can make whatever you want. I had also a question about slow motions. Sometimes I use slow motion in my video and I make them with my phone. Now, of course, you don't have to be a YouTuber or video maker. If you want to check how your tool performs, I think it's a very good solution. I have just one little problem with it. I have to film from the side. If I put my phone here with the movement of the RAM, the autofocus is always changing and my slow motion look like shit. You can make anything with a shaper except money. That's indeed a statement done by someone who doesn't know how to run a shaper. That's clear. In a previous video I made these parallels and I made a pair on the shaper and I made another pair on the milling machine. And I calculated on the blackboard, it's in the video, on the shaper 6 minutes. On the milling machine 30 minutes. Time is money, right? Of course, I don't have a problem with milling machines. I have one myself. And indeed, the milling machine is more versatile. You can make more different operations on the milling machine than on the shaper. That is correct. But don't say shapers are slow or you can't make money on the shaper. If you know how to run a shaper, I'm pretty sure you can make money with it. There was also a question about cutting forces. How much power do we need to cut through material? How much torque? Well, I have to disappoint you because I don't have any numbers. I don't know a thing about it. I bought this shaper. I worked with other shapers before in my life and I use them of course as is and it works. But specific numbers I don't know. And there was also a question about other material, like for example aluminium and all kind of plastics. Let's call them plastics because it's easy to say. I only have scrap steel over here in my workshop. I don't have any aluminium, so I don't have much experience with aluminium or all kind of nylons and Delrin, and I don't know, I can't help you with it. Steel, not a problem, but all the other things. Same with spring-loaded cutting tools. I never used any spring-loaded cutting tool in my life. On the shaper or on the lathe, I never used, so I have absolutely no experience with it. I know we use it for slotting and especially for form tools that make very large cuts, and it prevents the whole machine from chattering. So I think they work really well, but I never use them. I cannot answer this question. Congratulations! You are the only one who made it till the end of the video without falling asleep, and I think that's quite an achievement. To conclude, one last thing. Shapers are fun.